So now we'll be going on to analyze a malicious document. And now this malicious document comes in the form of a PDF file right here. At first glance, it appears that it's harmless, that it has no content, which is quite suspicious, but we will be going in to analyze it. First thing we want to do is just take a look at virus total scan. As we put in the hash of this PDF document, we can see that a number of security vendors have been flagged this file as malicious. 40 out of 61, in fact. Like, majority of security vendors actually detect this file as malicious, and we can see here that these are the things that they detect. Like, it's a PDF file. They detected this specific CVE, and the PDF contains embedded JavaScript in it. And we can also see some more details, like the different hashes, and also the file type, and something interesting, the command packer that we'll be using to help to decode this malware later on. So after we done our virus total scan, we'll be doing some simple string analysis. So first we want to do a quick base64 dump of the PDF file to see what strings that we can attach. So you can see here there are some readable strings, in fact, that we can see, such as flake decode, catalog, threads, procset, PDF. Okay, interesting. So once you've discovered these strings, we want to move on to another application that we can use to find strings inside this malicious document. So we'll be using bintext, which is a tool on the MATT workstation, this Windows 8 workstation. And so we'll just put this file into the input and see what it gives us. So from this we can actually find a lot more strings, and we can see a lot more PDF format tags like type, catalog, even JavaScript, procset, resources. So these are all interesting, and we'll definitely take note of this JavaScript one. So once we've seen all these strings inside, we want to do an analysis of the PDF document using a tool called PDF parser. A PDF ID, sorry, followed by PDF parser. So firstly, we do a quick PDF ID of this malware. We can see some PDF headers, PDF format tags like JS, JavaScript, open action, which are all suspicious tags. Open action involves executing code, and JavaScript, is code. So we want to use PDF parser now to kind of look into more of these objects. So first we're going to search the object JavaScript in malPDF. And we can see a few objects. And let's look into object 12 specifically. It references object 13. So let's just jump straight to object 13. And here we can see that it contains this PDF format tag, flake decode, and has a length of 7179. So this definitely contains some interesting content that we really want to look into and try and analyze. So we'll be using this command -f to just dump out everything. And here we can see a lot of characters, a lot of strings that we can't really make out anything like sensible or intelligible out of this. So now we can identify this as JavaScript code, and now we'll be going to deobfuscate this JavaScript code to try and make sense of what's happening. So to do that, I have created a simple Python program. Basically, I've just put in the whole all the strings that we extracted from here into this Python script, into the input, and after that it will just delimit it by the semicolon, and so hopefully it'll be more intelligible. So running the program, it gives us this, which after looking at it becomes pretty clear that it's some sort of substitution algorithm where this variable is assigned this value and so on and so forth. And we can see that there's a code block over here that comprises of a lot of these variables. So it's pretty clear that this is a substitution mechanism used by the malware to like encode its JavaScript. So now to decode this, we're going to use another Python script that I made. Basically, it just puts in everything above this block of code, like all these variables that were assigned values. It puts them into here. What it does is creates an empty dictionary, and it inserts all the variables into the keys and the values into the values of the dictionary. And after that, it takes this block of code and it puts it, and then it substitutes it. It iterates through every single variable, and then it substitutes the value inside the dictionary for the variable that it matches to. So running this program gives us this output. Oh yeah, I forgot to mention, there's also a second block of code which is much longer at the end of the text. So we found this short block of code that is actually quite intelligible. We can see a function, we can see while, and we can see char at. So we know that we're heading the right direction. So after this, we will be putting it into one compiler, which is a web-based compiler for JavaScript and a bunch of other languages. And so I organized it. I just cleaned up the code. This is the exact same output. After cleaning it up, it becomes quite understandable actually. And to test it, I just put in an input hello world, and when it runs, it produces this, and vice versa. This tells us it's a reversing function that reverses the order of the text. So now we can see here that the rest of these variables, there's a lot, all have this function which we found was a string reversing function. So then I created another Python program to basically do the same thing as the previous one, but just reverse a string and also clean up the text. So after running this, it produces this output. Again, we can see text like array, function, while. So we are definitely heading in the right direction. So now after so this is the output, and after cleaning it up, it looks like this. Here we can identify three different functions, this, and this. And the two important functions that we want to look into is this and this. So here we want to analyze what these two functions do. And firstly, the important part of this function is this encoded piece of string. If we do a bit of research, we can find that it's actually percent encoding, and in fact it's percent encoding a piece of shellcode. Right now we can't understand what it is because it's encoded, but we'll be decoding it later. One very interesting part of this malware is this collect email info, which is an unfamiliar function to us, so we're just going to be doing a bit of research on it. And by doing a simple Google search of collect email info malware, we can find that there is it's actually part of an exploit. So we just go to exploit DB, we just click this link. You can actually see that it's this specific CVE. It's actually a local buffer. You can see that it's actually a local buffer overflow. It's a Metasploit, part of a Metasploit module. So this actually matches up to what we first discovered in this virus total scan, which is CVE 2007 and 5659. So we want to look more into this specific exploit. So we just do a bit more research, click a few more links, and found out that's actually an Adobe exploit, and it was actually created a long time ago, and it uses this specific Metasploit module. And so as we look into it more, do a bit more research, we can kind of see that it's a Adobe Reader vulnerability that uses this malware to exploit it. So it's actually a critical vulnerability, and it was actually discovered very long ago. As you can see, the same CVE, and it only affects these specific versions of Adobe Reader, Adobe Acrobat Professional, and so on. So now we have discovered the purpose of this malware and what it was designed to do. What we can do now is to try and understand what specifically this piece of shellcode does. It may or may not work, but we want to try. So what we can try and do is to convert this into shellcode. How we want to do that is by doing a few simple steps. First we put this string of percent encoded characters, and we put it into a file called shell.bin. And after that, we can use peepdbf's interactive command called js unescape file shell.bin. This command basically unescapes the percent Unicode. And after that, we get these bytes with some text, but we can't make out any of this. So what we want to do now is convert it into an executable file. How we want to do that is we want to use another tool called shellcode.exe.py. We want to put unshell.bin, which is these bytes. I put it in a file called unshell.bin, and after that we want to put an output file, unshellcode.exe. After that, it reads the raw shellcode, it generates an executable file, and it writes the file to this. So now we have an executable file unshellcode.exe, and we'll try to run it and we'll try to analyze it. Moving back into the MATT workstation, the Windows 8 workstation, we can try and look into this file. We can use hxd, and we can put in this file as the input and see what we can make of it. So you can see a few strings, text, data. Scrolling down, you can see a lot of this which we cannot understand. Scrolling down, we come across something even more interesting, which is these few strings. Now these are Windows API calls, and they are definitely suspicious as to the functionality of this program. Now we want to just run this program to see if we can do some dynamic analysis of it. So we just run it as administrator, and a few processes pop up, such as dir host and svc host, but it kills itself after a few seconds. Going into procmon, after we run this, we can see a few processes detected, but we can't really make out much of it. This could be because that this malware cannot run specifically on this version, so dynamic analysis is pretty unfruitful. Although we couldn't really get out anything of the dynamic analysis due to probably conflicting versions, or the malware couldn't run on that specific version of Windows or the specific version of Adobe Reader, so we couldn't really analyze it. I think it was quite fruitful overall because we managed to find the purpose of this malware and the exact CVE it exploits. So that concludes this video on my analysis for this malicious document, and thank you for watching.